And so you'll get to see all my stuff off to the side. So it's a little bit zoomed in or zoomed out, but that's okay. So we're on proportions here. So my proportion is an equation that states that two ratios are equal. Equal. So that's the first blank up at the top there. Okay? So proportion, and that is an equation. So we really want to pay attention to that statement right there. It's an equation. We will see an equal sign between them. So it just is basically telling me two ratios are equal. Remember, ratios are also the same thing as fractions. So that we're just saying, are these two fractions equivalent? Maybe one's a scaled up version, one's the reduced version. That's it, okay? So to determine whether a pair of ratios form a proportion, we are going to check their cross products. So that's the next blank, okay? Cross products. So maybe you've heard this before, maybe you've heard it as the butterfly method, but here's what it tells me. It tells me if A over B equals C over D, so those are all different numbers there, then we're going to say that A times D, in other words, we're circling those cross products. Product, remember, means to multiply, and we're going kind of across and diagonally. We're saying A times D has to be equal to B times C. Okay, so that should look familiar. Drawing in those circles, that's also called the butterfly method. Okay, we can prove this to ourselves. So I'm going to give you the fraction 1/2. Okay, so 1/2. What is another fraction that is equal to 1/2 but maybe a little bit bigger? Yeah, 2/4, right? Or 3/6 or whatever. There's infinitely many fractions that are equal to 1/2, right? Those are the same. 1/2 is the same thing as 2/4. One's just not reduced, but they're the same thing. And so we can check this. Is 1 times 4 equal to 2 times 2? Is that true? Is 1 times 4 equal to 2 times 2? Yes, 1 times 4 is 4. 2 times 2 is also 4. So that's all we're saying. That's a trick that we have in math. If I have two fractions that are equal, then if we multiply those cross products, they should also be equal, okay? So for these first couple, we're just determining whether each pair of ratios or fractions form a proportion, or are they equivalent? Are they equal to each other? So I'll show you kind of the long method first, then I'll show you the trick, the shortcut. So for the full method, you can always take those cross products. I can always take 5 times 24, and I'm going to see, is that equal to 6 times 20? Okay, so then we can type that in. So you will need your calculator for today. 5 times 24 when we type in is 120. 6 times 20 is also 120. So yes, these are equivalent fractions. They will form a proportion. One is the larger version of the smaller one. That's all we're saying, okay? The other option that maybe your teacher has shown you in the past is something like this. 2/3 and 8/15. So we can ask ourselves the question, looking at the smaller fraction, what am I multiplying 2 by to get to 8? What am I kind of scaling it up by? 2 times what gives me 8? Times 4, right? 2 times 4 gives me 8. So then we have to make sure that if they are equivalent, then the bottom also has to be times 4. Is 3 times 4 15? No. So this would be a no. Those are not equivalent. So that's the shortcut. You can also think about it that way, because I know teachers have taught you that in the past. So we're going to do the same thing for number 3. We'll try that kind of shortcut method again. So I can look at the smaller fraction, and this really only works when I have whole numbers that will go into other whole numbers nicely, okay? Otherwise, then I might have to go back to the original method. So we can say 9 times what is going to take me to 54? What am I multiplying that fraction by to make it bigger? This one's harder because it's a 9 times 6. So hopefully we know our 9s. That always messes people up. So then to see if they're equivalent, we would also have to say that 7 times 6 is 42. Is that true?
Yes.
Yes. So these are equivalent, okay? So that's the shortcut. If you don't like the shortcut and that confuses you, we can always do the cross product method, okay? So number 4, this would be one where maybe the shortcut method is going to be really hard, because what I would have to figure out, 8 times what gives me 28? There is no nice whole number that goes into 28 that's divisible by 8, right? So this one, we probably need to go back to the original method, which is why it's so important to know the original method, where I can multiply. So I can say 8 times 45 is equal to 18 times 28, and I can check that to see if that's true. So 8 times 45 when I type in gives me 360, and 18 times 28 when I type that in gives me 504. So no, these are not the same. My cross products are not the same. Okay, so I'm going to jump down to number 8, and then you'll try 5, 6, and 7. So number 8, I like this one because we have decimals. So really with those decimals, I would always use the butterfly method, the cross product method, whatever you want to call it, because that's really going to be hard to try to figure out 9 times what gives me 16.2. I don't know. I'm a math teacher. I don't know what that is off the top of my head. So I'm going to go this way. I'm going to take 16.2 times 38, and I'm going to see if that's equal to 9 times 68.4. I'll go the long way and see if that's true. So 16.2 times 38 gives me 615.6. And then I'll type in 9 times 68.4 and see if I get the same thing as well, which I do. I also get 615.6. So we can say, yes, these are equivalent. So especially with those decimals, just by visually looking at it, we're probably not going to be able to tell, right? So you're going to have to show your work to see if it's a yes or a no. So go ahead and work on 5, 6, and 7. Here's what we should have had for 5, 6, and 7. You should have gotten 840 equals 840, 56 equals 56, and 27 is not equal to 27. So yes, yes, no. All right. So pretty easy stuff. And that's all we had to do for that first section is just determine yes or no. Now we're actually going to get to solving, right? This is an equation. So I'm actually going to find an answer. Your answer is going to look like x equals something or k equals something, whatever your variable is. So I'll go the long way, the cross product method, and then I'll kind of show you the shortcut again. But again, the shortcut can't be used for all your problems. So we need to know the long way, but you can also use the shortcut whenever you notice it, okay? So we'll do 3 times 16, right? It's the same thing as before. 3 times 16 equals 12 times x. It's just that now I have a variable. So I'm not going to multiply both numbers. One of them is a variable. So I can set up my equation. We know 16 times 3 has to be equal to 12 times x, which we really just write that as 12x, right? We squish them next to each other. So I can type in 16 times 3, which is 48. So my equation is now 48 equals 12x, and that's what I'm trying to solve. So this was exactly like the warm-up. I saw we got this right, but I'm hoping that we actually did this on our own and didn't just type in random numbers. So we're going to divide by 12. 48 divided by 12 gives me 4. There's my answer, okay? So because it's an equation, we're solving, right? We should have an equal sign. We should have x equals in the end. Okay, so that's the full method. I'll show you for number 10, you can use kind of that shortcut, right? Because if I notice my fractions, I notice that that smaller fraction is going to go right into that bigger fraction, right? 7 times what will give me 21? Times 3. So I know that that second fraction was reduced by 3 to get to the 7/8. 7/8 is the reduced one. 21 over something is the larger one. So if I multiplied by 3 and I have this equal sign, it tells me they're equal. I can say, well, then that 8 also has to be multiplied by 3 to give me that number underneath 21. So 8 times 3 gives me what? 24. So that bottom number, k, has to be 24. So this is the shortcut, if you notice it, right? But it can't always be used. It can only be used when you have something like this, where you know what the smaller number is going to go right into that bigger number, multiplied by a whole number, okay? Like for number 11, you probably don't want to use this method because I don't know 5 times what gives me 26. I don't know, 5 times 5 gives me 25, but I'm trying to get to 26. So I would go back to the cross multiplying method, okay? So I can multiply 26 and 6 together. That's equal to 5 times w, and we just write that as 5w. We multiply them so they're squished together. So then 26 times 6 gives me 156. That's equal to 5w. And again, this is the same thing as the warm-up, where I just need to divide by 5 on both sides. So we have 156 divided by 5, which gives me 31.2. Okay. Number 12. Number 12, if I take a look at this, this one we might be able to use the shortcut because I notice 9 and 63. I know that 9 and 63 go into each other, so I can use that trick method if I want. 9 times what is going to give me 63? Yes, 7 times 7. So it's going to be the same thing for A. I'm going to say A, which is what I'm trying to find, times 7 is giving me 14. So my question is, what times 7 gets me to 14? Yes, 2. Okay, so that would be my answer. We're going to say A is equal to 2. Okay, I'm going to do the evens with you guys. You guys are going to do the odds. So I'll do 14, 16, 18 with you. 18 gets a little bit more challenging. And then you guys will try some of that on your own. Okay, so 14. This one, I have a decimal as kind of that smaller number, right? So that's probably, I don't know, 1.2 times what gives me 4. I don't know. So I'm probably going to do the cross product here. So I'll multiply 1.2 times 11. That's equal to 4 times m. Okay? And so then 1.2 times 11, when I type that in, gives me 13.2 equals 4m. And now all I have to do is divide by 4. So I can type that in. 13.2 divided by 4, that is m equals 3.3. There's my answer. Okay, so this is always the option you can do. If you can't figure out the shortcut, that's fine. But I want to show it because I know some people were taught that way, and I want to make sure that you still know how to do it. Okay, number 16. So I'm kind of looking at my numbers. You could try the shortcut if you want it, but this one would be kind of hard. 8 times 8 gives me 64, but then I have to try to figure out what number times 8 gives me 2.25. That's weird. That's a tough one. So I would not do the shortcut here. I would just go back to the regular way of multiplying my cross products. So again, and everything that I'm circling is getting multiplied together. That's the whole point of circling it. Some of us are just circling and we don't know what that means. Or multiplying what's in my circle. So we have 2.25 times 8, that is equal to 64 times v, which is 64v. And so we can type in 2.25 times 8, which gives me 18, equals 64v. And now I can divide by 64 on both sides. And you want to type it in how we have it written. 18 on top, that's what we type in first, divided by 64. We will get a small decimal here. So I get 0.281. Which is why I'm saying shortcut method would have not been good here because there's no way you would have guessed 0.281. Okay, number 18. What do we notice that looks a little bit different about 18? Maybe what do we have extra in here? Right, there's a number, there's a 7 in front of the variable. So far we haven't had anything like that, right? We've just had the variable. We still set it up the same way. So I'm still going to create my circle, and I'm going to multiply what's in the circle. But it's just that now I'm not just multiplying by c, I'm multiplying by 7c. So we can say 2 times 7c. Then my other circle is going to be 15 times 8.4. And so I want to simplify here. So 2 times 7c. We just multiply the regular numbers. What's 2 times 7? 14. So that just becomes 14c. That's it. A lot of times people forget that though. And then we can type in 15 times 8.4, which gives me 126. And now I can divide. So I'll divide by 14 on both sides. And I get c equals 9. Okay? So that one just takes it to the next level just a little bit. And then if you notice on the bottom half, they get a little bit more complicated. But let's stick with the easy ones for now. I want you to work on 13, 15, and 17. We've gotten 3.8, 13, and 7. Or I guess I should say P equals 13. So those were my answers. So even if you're maybe finishing them up, I would write the answers down off to the side just so you know you're getting to them. But we should have 3.8, 13, and 7. Okay? So now let's go ahead and look at these last couple. They're a little bit different because what do we notice now about my proportion? What looks different about this? Yes, so there's x's and then we're adding things and subtracting things. So we've never seen a plus or minus in the fraction so far. So when this happens, we still use the same process, okay? So I can still say that 2 times 12, the cross product, I can circle those, 2 times 12 is still going to be equal to 3 times x minus 2. But it's really important that you do not write it like how I have up here. Do not just write 3x minus 2. The 3 is getting multiplied by all of that, the x and the negative 2. So what symbols do we need to put in there to show that that 3 is getting multiplied to both of those things? Parentheses, good. So what I would do, and what you would do whenever you get your homework as well, is let's fill in all of the parentheses for all of the rest of my problems here. So anything where I'm adding or subtracting like this, there's parentheses around that, right? It's a group. So parentheses are used for groups. Mm-hmm. Yes. Did you have a question? No, okay. All right. So that's what we want to do. You have to put parentheses or you're going to get this wrong. Because if you just put 3x minus 2, that's not what the problem is. We have 2 times 12, which is 24. That's equal to 3x. And I need to multiply the 3 times negative 2, which is negative 6. So notice how you would get that one wrong, right? Negative 2 versus negative 6, you're going to get the wrong answer.
Put them around each one so you remember.
Okay, so now I have my equation. This was what we did on the warm-up. So I'll walk through this. I want to move the number that's being added or subtracted first. So I'm going to add 6 to both sides. So I have 30 equals 3x. And then I'm going to divide by 3 now. Okay, so that's how we set up number 19. All right, we need to put the parentheses around them. 20 is the same way. So please make sure you have your parentheses around the a plus 7. I'm not doing this just to be picky, but because every year I see people get it wrong over and over and over again. Okay, so we're going to do the same thing. We're going to cross multiply the same way we've been doing. 10 times 2, I'm just going to write that as 20 at this point. I think we're good with that. 10 times 2 is 20. We're setting that equal to my other circle. 5 times a plus 7. A plus 7 is in the parentheses to show the 5 is getting multiplied to both of the a and the positive 7. So when I solve this, we have to distribute first. So I get 20 equals 5a plus 35 when I multiply. And now I can keep going. So we want to move the number that's being added or subtracted first, which is this plus 35. You don't want to move anything with the a. And the 20 is already on the other side, so we're definitely not moving the 20. So the opposite of plus 35 is to subtract 35 from both sides. And I'll zoom in here a little bit more. Okay, so then I can add down. 20 minus 35 is negative 15. That's equal to, bring down the 5a. The 35's at the end cancel. And now I have one more thing of just dividing by 5 on both sides. And negative 15 divided by 5 is negative 3. So that's the level that we will be practicing tomorrow. That's what's going to be on the test and the quiz. Or just the test. I don't think there's another quiz over this. We'll just do the test. So we want to be good with that type of problem. All right, 21 takes it up just one more because now I have 2 groups, right? I have an r minus 1 group and an r plus 6 group, meaning I'm going to have to multiply twice, which is exactly what that last problem of the warm-up was today. So I can still do my circles. I can do 10 times r minus 1. So that r minus 1 is in the parentheses. That is equal to 5 times r plus 6. So that's my other circle is going to be. Okay, so now I'm going to distribute 2 times now instead of 1 time. So I have 10 times r, which is 10r, 10 times negative 1, which is negative 10, 5 times r, 5 times 6 is 30. So that's step 1. So if you need to look back at the poster, it's always up here at the front. Step 2 is combine like terms. I have nothing to combine. I have 2 things on one side, 2 things on the other. That's it. So we move to step 3. get my variables on one side. So the trick I said today with the warm-up was we like to move the smaller amounts. What's the smaller r, 10r or 5r? 5r. So I would move that one. I would subtract 5r. It's a positive 5r. We have to do the opposite. And I would draw your line to show I'm going across to the other side and subtracting. So now I can add everything down. 10r minus 5r is 5r. Bring down the minus 10 equals 5r minus 5r cancels. Bring down the 30. So now that I have everything on one side, this looks exactly like those problems that we were doing all day and many, many weeks ago. We move the number being added or subtracted first. We look at the minus 10. So I need to add 10 to both sides. So when I do that, I can bring down my 5r. The 10s cancel. 30 plus 10 is 40. And last step is to divide. So I get r equals 8. Okay, so I'll leave that here. I'm going to get you started on 22, but then I want you to finish 22. So I'll get you set up. When we set these up, we always do my cross product circles. So we're going to take 4 times 5c minus 2 in parentheses. That is equal to my other circle. My other circle is 7 times c plus 10, all in parentheses. So I want you to solve that one the same way we did the warm-up and number 21. Once you get an answer, we'll come by and check that you have the right answer and give you the homework. Also, I'm going to stop the recording.